Today on educator.com, we're going to be discussing inequalities with absolute values. There are a couple of forms that inequalities with absolute values can come in. The absolute value of x could be less than n, or it may be in the form the absolute value of x is greater than n. And these are handled differently. Starting out with inequalities of the form the absolute value of x is less than n. What this means is that x is less than n and x is greater than n. In order to solve inequalities of this form, you need to solve these two related inequalities. The solution for this are values that satisfy both of these related inequalities. Remember, another way to write this would be, instead of x is less than n and x is greater than negative n, I can write it in a way that's clear by eliminating the two, instead of having two x's, just have one x and eliminate the word and just clearly show the restrictions on x. That x must be greater than negative n and x is also less than n. A very simple example would be if I told you the absolute value of x is less than 2. Think about what that means. Well, the solution set for this inequality is any number whose distance from 0 on the number line is less than 2. So I'm looking at the number line, and the absolute value of x is less than 2. So this inequality is satisfied by any number that meets those conditions. So I look and I see that any number that is less than 2 but greater than or equal to 0 on the number line would satisfy that, because if I take any number in here, if I take 1.5, the absolute value of 1.5 is less than 2. If I take 1, the absolute value of 1 is less than 2. Also, any value greater than negative 2 would satisfy this. Because if I look here, if I have negative 1.5, the absolute value of negative 1.5 is 1.5. That's less than 2. So the absolute value of any numbers in this range is going to be less than 2. Therefore, I could write this instead as x is greater than negative 2 and x is less than 2. Or I could form it out into two related inequalities. X is greater than negative 2. So we're just writing this out into two separate inequalities. And x is less than 2. Okay? So what this is telling me, the absolute value of x is less than 2, is that x is greater than negative 2, and it must also be less than 2. It has to satisfy both inequalities. The solution set for this must satisfy both of these related inequalities, which can also be written like this. For inequalities of the form the absolute value of x is greater than n, then the two related inequalities would be x is greater than n or x is less than negative n. So notice now we're saying or, not and. To solve inequalities in this form, solve these two related inequalities. The solutions for this are those values that satisfy either or both of these equations. We just talked in the last slide about a situation where you had to satisfy both related inequalities. Here, you just have to be able to satisfy one or the other, or you can satisfy both. But you don't have to. If a solution satisfies one, it's part of the solution set. For example, if I say that the absolute value of x is greater than 4, what that tells me is that x could be greater than 4, or x may be less than negative 4. visualizing this on the number line. Okay, looking at what this is saying, the absolute value of x is greater than 4. That means that this must be a value of x that is greater than 4 from 0 on the number line. X is greater than 4, satisfies this. Any number for x, any value of x that is greater than 4 will have an absolute value of greater than 4. Now, the other possibility is that x may be less than negative 4. Because if I take an absolute value of any number over here on the number line, extending out my number line, if I take negative 6, the absolute value of that's going to be 6. That's greater than 4. If I take negative 100, the absolute value will be 100. That's greater than 4. Same here. If I take any values all the way out over here, 20, the absolute value is greater than 4. So these are all solutions that satisfy this inequality. So are these. You don't have to meet both these criteria. In fact, you can't meet both these criteria. You have to meet one or the other. When you're solving inequalities in these two forms I just talked about, the first thing is just to stop and look at which form am I dealing with. The absolute value of x is less than n, or the absolute value of x is greater than n. And then think about the separate approach for each. In example 1, I have an absolute value of z minus 4 is less than or equal to 6. So I recall that this is that form x is less than or equal to n. And I'm going to have two related inequalities from that. The two related inequalities that I'm going to find is that x is less than or equal to n, and it's greater than or equal to negative n. Translating that, applying that to my example, I'm going to have two related inequalities. Z minus 4 is less than or equal to 6, and z minus 4 is greater than or equal to negative 6. The next step is to solve these out. So first, you need to find the two related inequalities, and then solve each. And realize that the solution set has to satisfy both related inequalities. Okay, starting out with z minus 4 is less than or equal to 6. Just writing this a little bit differently over here so we can work with it. Okay, I have z minus 4 is less than or equal to 6. All I have to do is add 4 to both sides to solve this, and I'm going to get z is less than or equal to 10. And z minus 4 is greater than or equal to negative 6. Again, I'm going to add 4 to both sides, which will yield z is greater than or equal to negative 2. Representing this on the number line to visualize it. Okay. I have to meet both of these criteria. Z must be greater than or equal to negative 2, and it must also be less than or equal to 10. And I could write this out another way, putting z in the middle and showing that it's greater than or equal to 2, or and that it is less than or equal to 10. So this is the same as this and the graphed version. In this example, I recognize that I had the form, the absolute value of an expression is less than or equal to n. And this works for a strict inequality when you don't have the equal to here. Same idea. Then I found my two related inequalities. Then I solved each, and I have a solution set that satisfies this inequality with an absolute value. In the next example, again, I stop for a minute and I look at what form I have. And I have the absolute value of w plus 5 is greater than 4. So this is in the form, the absolute value of x is greater than n. This tells me that x is greater than n, or x is less than negative n. Those are going to be my two related inequalities. So writing that for this inequality, I get w plus 5 is greater than 4, or w plus 5 is less than negative 4. Now it's very simple to solve. Subtract 5 from both sides, which is going to give you w is greater than negative 1, or w is less than negative 9, representing this on the number line. Okay. I know that w could be, there's a set of solutions, w is greater than negative 1. Does strict inequality, so an open circle. My solution set does not include negative 1. Or w is less than negative 9. Again, an open circle. So any values in this range and any values in this range will satisfy this inequality. So this time I had an inequality in the form, the absolute value of x is greater than n. So my two related inequalities were these two, which I solved out, and my solution set is all of these values and all of these values, where w is greater than negative 1 or w is less than negative 9. Again, this time I have the form, the absolute value of x is less than n. So I'm going to stop and think about my restrictions. And what I'm going to have is that x is less than n, my two related inequalities, and x is greater than negative n. Writing that for this, I get 3k minus 4 is less than 8, and 3k minus 4 is greater than negative 8. Adding 4 to both sides gives me 3k is less than 12. And then I need to divide by 3 to isolate the k. So for this inequality, I get that k is less than 4. On this side, add 4, same thing. So I get 3k is greater than negative 4. Again, dividing by 3, and I get k is greater than negative 4/3. Okay, so k has to be less than 4, but it also has to be greater than negative 4/3. Or writing that slightly differently, k is greater than 4/3 and k is less than 4. On the number line, so for negative 4/3 is the same as negative 1 1/3, so that'd be right about here. And it's a strict inequality, so I use an open circle, and that's one of my boundaries. The other one is that k is less than 4. So the solution set is represented graphically right here on the number line. So I saw that I had the form, the absolute value of x is less than n. I found my two related inequalities. 3k minus 4 is less than 8, and 3k minus 4 is greater than negative 8. I went ahead and solved those and found that k must lie between negative 4/3 and 4. In this example, I have the form x is greater than or equal to n. So I'm going to write out my two related inequalities, which are 3y minus 8 is greater than or equal to 24, or this form, we use the word or for the two related inequalities, or 3y minus 8 is less than or equal to negative 24. Go ahead and solve both of these and see what you end up with. So adding 8 to both sides, if I add 8, I'm going to end up with 3y is greater than or equal to 32. Then I'm going to divide by 3. That's going to give me y is greater than or equal to 32 thirds. To make this a bit simpler, I'm going to change it to y is greater than or equal to 10 and 2 thirds. Solving for this side, I'm going to add 8 to both sides, and I'm going to get 3y is less than or equal to negative 16. Dividing both sides by 3, y is less than or equal to negative 16 thirds. Again, making it a little bit easier would make it y is less than or equal to negative 5 and 1 thirds. Okay, again, it's or. On the number line, I have that y could be greater than or equal to 10 and 2 thirds. So about here, and we're going to have a solid dot. Or y is less than or equal to 5, negative 5 and 1 third. So looking at the form that I had, I know that I can come up with two related inequalities, that 3y minus 8 is greater than or equal to 24, or 3y minus 8 is less than or equal to negative 24. I solved both, and I found that y is greater than or equal to 10 and 2 thirds, or it's less than or equal to negative 5 and 1 third. So today we worked with some inequalities that involved absolute values. Thanks for visiting educator.com.